much for joining us on this next session from the FuturePrint Tech Fest. And I am very pleased to have with me a couple of guests here and to be talking a little bit about an area and subject that we perhaps haven't discussed much on the rest of the content that you've seen today. I'm very pleased to have Tobias Lang from Marabou. Hi, Tobias.
Hi, Fraser.
And Tim Snell from Koenig & Bauer.
Hi, Fraser. Nice to meet you. Pleasure.
Good to see you both. And this session really is going to talk a little bit about glass printing, digital print on glass. And it's also going to cover that area that we've been talking a little bit about in the day, which is collaboration and how important collaboration is in projects. And you'll see and hear from the guys very much a working partnership to deliver a very, very interesting project of printing digitally on glass. So I'm going to pass it over to Tobias, who's going to kick off with a short presentation, and then Tim's going to follow with that a few words as well, and then we'll have some questions at the end. So Tobias, over to you.
Thanks, Fraser, for this great introduction. Hello from my side. I'm glad today to speak here at the FuturePrint Festival, together with my colleague from Kammern, Koenig & Bauer. And we will speak about today our new innovative printing method on glass. My name is Tobias Lang. I'm the product manager for Digital Inks. I'm responsible for the UV ink regarding the graphical and industrial application. And I will speak about the ink part, what we did on the ink side. And later on, I will overhand to my colleague from Koenig & Bauer, Tim Schnelle. He's the sales manager at Koenig & Bauer Group for the business unit Cayman and the specialist for the container and holoware printing. So I think most of you have heard about the mega trend personalization. You can meet it like anywhere in your daily life. I will give you an example. In former days, you want to watch the television, you had to choose the program. And now you can go to Netflix, or you can listen at the radio program, to Spotify, and choose your program when and what you want. So in this presentation, I might get a little bit deeper here. I will go here a little bit to the demand of personalization. How is it regarding different generations, and the opportunity to capitalize personalization. So let's start on the left diagram. It shows different generations: the boomers with 27% of demand for personalization, 32% of the Gen Xers feel this demand. The millennials have a demand of 45%, and up to the Generation Z, there's a demand of 53%. What we can see here, I think it's two topics. The first thing, it's an increase of the personalization of the demand. And there's a 40 to 50% of interest in personalization right now, versus usage below 20%. That means there's a big gap which needs to be filled from the market. Let's jump to the right side. This is the option of capitalize the personalization. We have here the brown bars, which shows consumers who are willing to pay 20% above the price list. And we have here the red bars. These are consumers who are paying 10% above the average prices. So if I calculate now over all the industries, you will have 70 to 80% of all customers who are willing to pay 10% more for personalized products. And almost the half of all consumers, are willing to pay even 20%. That will bring us to the point that personalization can be used to generate a monetary effort or benefit. But how does it fit to our new innovation? So, well, we have developed new, really digital printed RealF technology. We have here on the left side the conventional glass production, which is more or less mass production. And on the right side, I have on my presentation the printed embossing technology, which is fully individual. You can fully individual print structural haptical effects on glass container. Let's start on the left side. So the conventional glass production works, you fill in the hot melted glass, and these were filled and formed by forming tools, embossing tools. I think you can easily recognize that individualization is quite difficult here. It is just economical for high volumes. For example, I will give you an example. Even big companies like Coca-Cola can generate their unique embossing part, a unique glass form, but it's just for this kind of industry. So let's jump to the right side, the printed embossing technology. Our technology is fully digital. That means fully individualizable and also economical in customization. We can downsize our batches to piece one, so you can produce unique parts. And I think this will bring us to a new kind of market. For example, craft breweries or wineries. Craft breweries, you will met in the past 5 years, you met it at the supermarket more and more. Craft beer is a trend, small breweries, small industries, and also local wineries. For these kind of industries, it is interesting to generate unique glass containers. On the other hand, also for the big players, it is interesting. We are thinking on limited editions for major event, for example, an AC/DC concert or a football game, or even a good bottle of whiskey. You can print on the glass container. This whiskey is produced in barrel number 125, for example. But this is not all. Our new technology, you can see here the first glass, is really exceptional. Of course, we have this individualization thing. We can downsize it. We can produce unique parts, but there are also some other benefits. I speak about contour sharpness. It is a totally digital process, which means we can print small dots in really fine contours, fine details, graphics. If you compare it to the conventional process, I think with our new technology, we set new standards. Such a contour sharpness is not achievable by the conventional process. Also, and I think a lot of you are designers, we increased the design freedom. It is a usually digital printing process, and we can combine it with the 4C process, with the color process. So it is possible to combine haptical and visual effects, color and structures. And that makes it fully new design freedom. If you have such a glass, printed embossing glass in your hand, you can easily recognize that there's a maximum transparency. It's not only look like glass, it also feels like glass. And of course, it's a glass, so dishwasher is a really important thing. Our glass, our new technology is dishwasher resistance. More than 500 cycles are easily achievable. For example, I'm using a glass for more than half a year, and it also looks like the first day. And all in all, to sum it up, it is economical. You can produce unique parts, unique glass containers in a totally economical process. I will now overhand to my colleague, Tim, who will speak about the machine and the process.
Yeah, and I will give some examples as well. So thank you, Tobias. Important to admit is also that we are not talking about just cylindrical items like you saw on the drinking glass before. No, that's not the point. And the reason for that is easy. So Tobias has already mentioned some typical realistics and benefits of the printing process. And additionally to that, we have one key benefit, in my opinion, and that is that we have a non-impact printing process. So we have to no time contact to the surface. We are shooting the drops onto the article surface, and in combination with the various axes we have implemented in the machine, we are always in the position to bring the article into the right position, into the closest as possible position under the printing head. And that's definitely a key factor, because we can also print complex geometries and shapes, as you can see on the craft beer glass in the middle. I have highlighted few areas on the glass where definitely conventional processes are reaching the limits. Just an example, screen printing. So one more benefit and one more big advantage of the process itself. Yeah, and now I will go back a little bit in the history of our innovation process. So yeah, perfect. So that's mainly where we started. So digital printing on a non-flat substrate is nothing completely new. So we have placed over 25 machines already in the market. I call it the standard 4C process. And then we were looking for some ways to extend the diversity of the decorations. And this was definitely the first step. Like you can see on the leaves, we added some fine structures into the decoration. And this was the first step. And we definitely opened some, as Tobias already mentioned, some doors for designers, more design freedom, more diversity. And we then relatively fast identified the potential of these haptic effects on glass, not only on glass, and started to work together with Marabu, and we went a step further. And this is mainly the result of our collaboration. We both, so Marabu and Koenig & Bauer Kammern as well, we had the demand on ourselves to push that technology further. And in my opinion, we did that with success. So I've added some more sample, or one sample, it is the same glass, to give you an idea what's possible. And suitable for this process are also small and fine details on the glass, like you can see on the left photo. This is a landscape, a map, which you can see on the backside of the glass from the right photo. So how the we print layer over layer to build up the relief without any reduction in time or quality. And this is also suitable for clear relief printing of higher and thicker graphics, like you can see on the right photo with the ampersand. So and that's not all. This is the next step, the combination of both of the standard 4C digital printing process on articles, in the combination with that relief printing, and this is how a result can look like. So there are so many possibilities, design freedom, and especially now, extraordinary designs are no unrealizable pipe dreams anymore, in my opinion. That's fact, and yeah, that's possible now. So at least I've added you a typical digital workflow, how it can look like in the B2B segment as well in the B2C segment. So starting by the customers, our main topic, and that was the topic Tobias started with, individualization and personalization. So we have a personalized image like the photo of a colleague of mine. Then it follows up by the digital prepress, which is definitely key in digital printing, as you know. So optimizing the data and convert it into for the machine usable data as well. So then we are going into the printing machine, printing the article. And after a few seconds, you got that personalized item in your hands, like you can see on the right photo, and we're ready for the end consumer. And just to give you an example, for our digital printing technology, we have mainly two machine platforms in which we are able to implement such technology. This is on the one hand the K15 family, which you can see on the above photo. It's an indexing table machine. Up to 60 articles per minute, pure digital printing. That's important to admit. Yeah, this is a concept for mid to higher volume order runs. And on the other hand, we have our linear machine concept, DK20. This is the photo below. And this is a machine concept which offers maximum of flexibility. So for small up to mid order runs, absolutely fast changeover times. And yeah, just to give you a short example, I don't want to get too deep in detail. So I think we can go over to the partnership and to the things.
So many thanks, Tim.
Together.
Many thanks, Tim, for this great explanation. I really like the designs of the 4C and the haptical structures. I think we showed here in this really challenging project, which is technically really challenging, we showed what a cooperation can achieve. I think we combined the know-how of chemical and mechanical engineering. So from our Marabou specialists, our Marabou chemists brought these know-how about the interaction of polymers and pigments, and our colleagues at Koenig & Bauer Cayman, they brought up the know-how about the print technology and, of course, the manufacturing of printer. Together, these technicians and chemists, we could adjust our chemical formulation on this process. And I think this is one of the key factors why we could achieve such great print quality.
Absolutely.
Our R&D departments work closely together. I would say nearly every week we had a telephone conference. We had several visits at each factory and also at the customer. By the way, I think it is a big benefit for our customers that they can speak to both. They have the printing experts at the Cayman, and they have the ink, the chemistry experts at Marabou. And yeah, I think last but not least, the ink and the printer both is manufactured in Germany, and I think it's quality made in Germany.
Thank you very much for that, gentlemen. That was both helpful in terms of putting the context around why this product is needed. You know, I mean, as Tobias said right at the front end, the trends, the mega trends that are influencing the way people buy. And let's be honest, the next generation of consumers, they are looking for personalized, individualized products. So everything you say is very true. And it gives anyone looking at this that great opportunity to create value quickly, you know, using this technology. Now, what I want to ask you is, in a way, this is a new technology delivering a clever solution. Do you sense that we're kind of replacing traditional screen here, traditional analog technology? Is that what's happening, Tim?
Yeah, that's a good question, Fraser. I don't think that we compensate, for example, screen printing, but this technology definitely is offering more variety, gives you more flexibility, and also in case that everything is going faster, anything has to be, or there's a demand, a request to have personalized items. This process offers you the let's say extension. So also the screen printing is definitely a process, a reliable process, known for years, absolutely. But especially in case of article geometries, shapes, and that small batch sizes, it's good to have that technology.
Yeah, sure. And just picking up on that, you mentioned it, and obviously Tobias would probably back this up. It's quite a challenging thing to print digitally on a curved surface.
It is, yeah. It's not easy.
How do you do it? What's the art to it? What's the magic behind it?
Yeah, it's on the one hand absolutely stable, and to have a transport system with the highest possible precision and accuracy. So then we have to integrate state-of-the-art inkjet technology as well. There's also absolutely important, you all know, the basics of digital printing. We need precision, we need accuracy, and as well we need the combination with for the article and the demand in case of adhesion, etc., the perfect matching type of ink. That's a combination of the machine transport, the transport system, the inkjet technology itself. Software is a big point.
I was going to say, software obviously has a lot of influence over that in terms of managing how the ink is deposited. Tobias, just tell us a little bit from Marabou's point of view. Exactly as you said, you are specialty print ink manufacturers. So you kind of know your stuff in this. And obviously printing on curved surfaces is challenging for ink because it is what it is. It's not flat and therefore it can break up. What's your view on this?
Well, I think, I think this is one really important part of the benefits of our technology. And I think it is made by the quality of the inks. The ink is always a dispersion. It's always a mixture of liquids and solids.
Yeah.
And I think it's a quality. It's how is the particle size of these kind of pigments which are in these in the inks, in the dispersion of the inks. And I think this is makes us is a trick or is a benefit there. That there's a really small particle size range and really definitely defined in, and this is a kind of quality what makes our inks such exceptional.
Sure. And is this just applicable for glass, or can we put this on metal or plastic or
as well?
Other? Yeah.
So where we are not able just to print on glass articles. Also on plastic, metal as well. So quite flexible.
That's interesting, isn't it? That gives a lot of.
It's always, I'm sorry, but it's always important to bring the article, whatever shape it is, into the right position, as I mentioned before. That's key. Yeah.
Yeah. In terms of the ink layers, is it multiple layers, Tobias? Are we talking about multiple layer here?
We're talking here about a single pass process, and it is if you colorate it. We're speaking about a multi-layer process.
Right.
You can multi-layer it white, CMYK, and the varnish, or these embossing or this technology. It is a multi-layer. You can set different kind of layers. It's depending a little bit how big the end film thickness should be.
Yeah. You talked at the beginning, Tobias, about kind of those mega trends. Obviously, one of the other mega trends is sustainability. How do you see that fitting with this technology and with these inks and what you're doing here?
Well, I think we have to see it on different levels. I think if we mainly a lot of glass containers are decorated with inorganic inks.
Yeah.
If we compare it, for example, with this ink, our ink is born or is organic ink. It is from the organic chemistry. So also our pigments are organic pigments, are built with carbon, more or less. There's no heavy metals in it, like lead or cobalt or something like this.
Yeah.
And I think this is a big benefit, especially you are speaking about sensitive products.
Sure.
Or glass industry is also a food and beverage product. So it is, I think it's an important part. I think the next thing is we are speaking here about UV-borne inks. That means the technique behind is that you curate the ink by UV light or LED light. It's a combination of both.
Sure.
And it's just a short lightning or UV lightning, and the ink is cured. I compare it now to the inorganic inks, which are cured at high temperatures. You need a really big oven, 600, 700 degrees. And if I now see the energy saving, I think this is a big effort for the LED-borne ink.
Yeah.
And and I think in such times like CO2 is a big mega trend. We have this climate change. I think this is a big point. And last but not least, I think the recycling. I think recycling is getting more and more fancy, more and more. We need it. We need to save our raw materials.
Sure.
And you don't want to waste your glass.
No.
By printing it. So I think these varnish, these who will build these haptical structures is fully built of carbon.
Yeah.
So and carbon oxidized in the hot glass melt. So it's recyclable.
Yeah, brilliant, fantastic. And just I want to pick you up just on the point you made about design freedom. And I think both of you kind of mentioned it. It's quite important here, isn't it? That, you know, short run production, digital production just gives you design freedom. I mean, the ability to try things, to try something or to do a short run, as you said, for a sports game or you know, personalized. It's such a great advantage, isn't it, in terms of business opportunity?
Absolutely. There are so many possibilities how to build up a business with such technology. It's fast, innovative, flexible, big factors. And there's coming a lot together. So on the one hand, we have the digital printing process itself, common 4C process, which enables you to print also photorealistic images, where, for example, screen printing or other processes are not that strong. In combination with some areas on the article where conventional processes can't be applied.
Sure.
In combination with the haptic effects. So there are so many possibilities, so many ways extending the diversity in the decoration and offering in the end decoration freedom. That's the point in my opinion.
Yeah, and I also think you mentioned haptics a few times, and I think there's clearly a sense, isn't there? The brands quite like haptics because it gives an added something, you know, if you're holding and you're feeling and it feels like something.
That's definitely the point. You feel something.
Yeah, I think you're right. Tobias, did you want to add anything there?
I think the feeling, the haptical structure is a big effort. And also what Tim mentioned is we can print on curved surface.
Yeah.
I think this is really unique because digital is the only tactless print application method. And this will give designers a totally more freedom of opportunities. And of course, the combination of the color and haptical effects. Sure. And you will have some, I will always call it deep effect, that you combine it in different layers. And I think this is really, really clever technology.
Yeah. On that note, as we just come to the end, sorry, Tim, I just want to ask one thing of both of you that's important, really. This is all about collaboration. And, you know, there are options for people to go and buy inks and technology from one company. Tell me why it's so valuable to come to you to this partnership for this product and this solution. Tell me why. Do you wrap up by giving me the reason why? Tim, let's start with you. Oh, sorry.
Sorry.
Now it's Tobias' turn.
Let's do Tobias first. Tobias, please.
I think we got the best of both worlds, the chemical world and the mechanical world. Yeah. You have these specialists from Koenig & Bauer Cayman, and you have our specialists at Marabu. And I think it is the adjustment from the ink to the process, which is necessary to get such a high quality. I think we are speaking here about a high-tech technology. And I think it's a big effort, a big benefit for our together customers, because they have always both contact persons regarding product safety, regarding chemical laws, regarding application parameters. Cayman has a great support for to learn new customers on their process. I think, and this is a big benefit for our customers. And I think this is the way we work together.
Yeah, thank you. And Tim, I let you have the last word on this. So as we wrap up,
that's very kind.
Tell us from your point of view.
No, I think Tobias brought it to a point. Definitely, we are delivering the technology, and I think that we know what we are doing, not only in digital printing and printing machines in general, and in the past years, especially also with digital printing, and everyone who got some idea of digital printing and knows the process roughly knows that just both in combination can bring you to a result in case of, on the one hand, adhesion, and on the other hand, definitely on printing quality. And together, when you have this both screws and working together, as Tobias mentioned, hand in hand, and we did that, and we're already still doing that. That's kind of combination of German engineering.
The best, don't you? You get the best
result out of it. Yeah.
I think that point you're making, both of you are making, is something worth reconsidering. That you are Marabou specialist in inks. You are Koenig & Bauer and Kaman specialist in making machinery. This is a unique product. It is not an off-the-shelf piece of technology and delivering something. It's delivering something different. That there isn't an off-the-shelf alternative, and what you've got here is something that's been built to do the job, and that's what's interesting. And both sets of companies are specialists in what they do to deliver something in the finality. And I think that's really what we've been talking a lot about today, is about this importance of collaboration on this inkjet journey. So gentlemen, thank you very much. I really appreciate that. It's been an excellent session, very comprehensive. Both of you really giving us some informed thinking, and pleased to have you with me. Thank you very much, gentlemen.
It was a pleasure.
Thanks, Fraser. It was a pleasure.